All right, so continuing with our transcendental functions, we have inverse trig functions today. And I'm going to split this into two videos again. We're going to do derivatives first, then I'll do another video with integrals. There's quite a bit of difference between them, so we'll go to these. I'm going to do a proof of this first one for the inverse sine of x. I'll give you the next two formulas. We just don't have time to do all of them. If you do want to see them, let me know, or I think they're in the book. You can probably find them online as well. So y equals the sine inverse of x, or the inverse sine of x. We don't know how to do that. But inverse sine of x, we can just take the sine of both sides and fix that. We get sine y equals x. Well, now we can take the derivative implicitly. The derivative of sine y is cosine y dy dx. That's what we're looking for, is the change of y over the change of x. Derivative of x is 1. Dy dx equals 1 over cosine y. Well, that's hunky-dory, except for I wanted that in terms of x. Well, luckily we remember all of our SOHCAHTOA, right? We can change this to be sine of y equals x over 1. That will allow us to establish a right triangle, where y is our angle here. This is sine, so opposite would be x, hypotenuse would be 1, and we'll just call this side a over here. We want to figure out what? Well, we want cosine of y, right? Cosine y. Well, cosine y equals the adjacent side, hence the a, over the hypotenuse 1. So if we can figure out what a is, we can figure out what cosine is. Well, that's easy. We got a right triangle, 3 sides. A squared plus x squared equals 1. A squared equals 1 minus x squared. So a equals plus or minus, but we're going to go with a plus, 1 minus x squared. Because we're going to pretend we're in the first quadrant, because we like everything in the first quadrant. So we have that. So dy dx, or the derivative of the inverse sine, is 1 over the square root of 1 minus x squared. Which, that's pretty unique. Every time we've had a derivative or integral so far of a trig function, we've always gotten a trig function. Now we're getting a radical, a rational radical. So that's interesting that we're starting to link all of our functions together. The derivative here of the inverse secant is 1 over, it's the most complicated one, it's 1 over the absolute value of x times the square root of x squared minus 1. So these two are similar. If you'll notice, this is a constant minus x squared, this is x squared minus the constant, and it has the extra thing on the outside. Tangent one is the easiest, I believe. The derivative of inverse tangent is 1 over x squared plus 1. So I wrote all of those up there for you as a quick reference for us to do this next page. Notice that all the cofunctions are just negative, have that negative sign like the other derivatives did, but otherwise they're exactly the same. Okay, so let's use these formulas to solve these derivatives. The derivative of the inverse sine of x squared is 1 over, so we're using this formula here, the square root of 1 minus, now we're going to take this inside, put it in there, so we have x squared, that was the inside, then we're going to square it, then, yep, you guessed it, chain rule. And we're going to chain x squared into 2x. So we get 2x on top, square root of 1 minus, what is x squared squared? That's x to the 4th. Tangent. 1 over 1 plus this squared. So square root of x plus 1 squared times the derivative of this inside. Well, inside function looks like that. So you have 1/2 x minus 1 to the negative 1/2. If we did chain rule here, we'd get a 1. So we're done with that. So 1 over 1 plus, square this, x plus 1 times 1/2 times 1 over x minus 1. Oops, that's a square root. So if we simplify this, we get 1, nothing in the numerator. We have 1. We've got a constant of 2. This becomes x plus 2 and a square root of x minus 1. Cool. Secant. Okay, so this is the complicated one. We're going to do 1 over absolute value of the inside, absolute value of 3, negative 3x, times the square root of the inside squared minus 1. Simplify. Oops, chain rule. Chain rule of this, derivative of negative 3x is negative 3, so times negative 3. So negative 3 on top. The bottom, absolute value of 3, negative 3 becomes 3. We don't know what x is, positive or negative, so we have to leave it like that. And the square root of 9x squared minus 1. This 3 and this 3 can cancel because they're factors. Everything's being multiplied there. So I have negative 1 over absolute value of x, square root of 9x squared minus 1. Now, why would I put a definite integral in the derivative section? Well, these inverse trig functions can show up as part of our u. We see we have u to the inverse tangent here. That's because we're going to have that be our u. Well, that's okay because the derivative of that is 1 over 1 plus x squared dx. So the whole denominator in the dx becomes our du. The power becomes u. We have the integral of e to the u du. Plugging in 0. What angle gives a tangent ratio of 0? Well, that's 0. What tangent value gives what angle gives a tangent ratio of 1? Well, that's pi over 4. All right, so let's integrate. When we integrate, we get e to the u, evaluated from 0 to pi over 4. Plug in e to the pi over 4 minus e to the 0. We do have to take care of this one, e to the pi over 4 minus 1. All right, that is inverse functions, or inverse trig functions.